Okay. So what happens in hydroboration reaction, tell me? Alkenes converts into alcohols. What type of addition we discussed? Syn addition, perfect. One more thing, like Marconi-Kafrol, anti-Marconi-Kafrol. Product similar to anti-Marconi-Kafrol. Okay, let's discuss all reactions here itself. Let us conclude yesterday's and day before yesterday's discussions. See, I am just adding like B2H6, like hydroboration now. First we will discuss with this. H2, B2H6, NaOH, H2O2. Tell me what happens, what is the product formed? Alcohol. Where OH, where H? Yeah. So tell me. OH, H. Yeah. Next. Next this one. Here I am writing H. See, simply they will mention like this. H3O means what? Like H2O plus H plus. Like you are adding water in acidic medium. So now water hydrolysis, like acidic hydrolysis you should say. So tell me what is the product form? First what we need to add? Acid now H plus. H plus you add? Where to add? Terminal side. Because here more stable carbocation. There you add water. So what is the product formed? Alcohol only. But this is 2 propanol, this is 1 propanol. So this is anti-Marconi-Kafrol addition. This is Marconi-Kafrol addition. Okay. Next one is OM-DM reaction. What is the reagent we will see? Like H2O, Hg, OAC twice and NaBH4. So now what is the product form, tell me? Alcohol only. But where H, where OH? Terminal H, here OH. This OH comes from water. Here H you are adding now, that comes from NaBH4. Next. Where you will add this HBr to this? Tell me where? Say something. Br minus? HBr is an acid. What it will provide? So add H plus first. Terminal H plus. Middle? Like simple Marconi-Kafrol product only now. Next tell me. HBr with H2O2 like this. Per acid is given. Now what happens? Anti-Marconi-Kafrol. So what happens? Br. Okay, don't by heart the things. Try to understand the concept. Next. Yeah, that's it. These are the things you need to have some idea. Next. See, chemical properties of alcohols. When you react alcohol with sodium metal. See what I told you, sodium metals are like alkali metals are what? So whenever they react with something, what they will do? They release one electron, become positive charge. That electron is taken by the acidic protons, releases H2 gas. So now or if this is removed as H plus and from here electron is taken, so it becomes O minus, Na plus H2 gas is released like this. Okay. Now see, they are treating with sodium hydride. NaH means Na plus H minus now. So this hydride will take this H and becomes RO minus Na plus H2. Okay. See, this NaOH is there now, this is a base. But it is not reacting with alcohol. So I can say simply no reaction. So from this, what you can conclude? Alcohols, like hydrogen is there now, that is very weak acid. I mean very weak acidic proton, very weak acidic proton. See, if it is reacting with NaH, like NaH means H minus. H minus is stronger base than OH minus. Like what you studied till now, NaOH is a base like that you studied. Okay, but I am comparing relative basic nature, I am comparing with H minus and OH minus. So who is stronger base? H minus. See, it's very simple ma. You know electronegativity now? a less electronegative atom with negative charge is more basic than more electronegative atom with negative charge. What is my statements once again, tell me? A less electronegative atom with negative charge is more basic than a more electronegative atom with a negative charge. It means you just tell me CH3 minus I am writing, OH minus I am writing, NH2 minus I am writing, and F minus I am writing. Which is more basic? Tell me. Least electronegative is? So CH3 is more basic now. Next after this, NH2 minus, next OH minus, least is F minus. This is a basic nature order. Okay, and here what I have included, H minus. Now which is least basic? So then definitely here H minus. More highest basic is which one? H minus. Clear everyone? Clear or not this one? What I told you, least electronegative, more negative charge. Okay. Next, tell me. Here it is not reacting. See, this is called CH2 group is there, na? CH2, N2. So this is called like diazomethane. What is that? Diazomethane. So this diazomethane with alcohol, no reaction. What I am saying? No reaction. Now same diazomethane in presence of BF3. BF3 means Lewis acid, na? So the Lewis acid increases the rate of reactivity. Therefore in presence of BF3 the reaction is taking place. Now what happens is R group as it is, O as it is, how many hydrogens are there here? 2 and 1 carbon, and this hydrogen, overall it becomes CH3. Okay, directly it is no reaction, but in presence of Lewis acid reaction takes place. Now NaHCO3 is there, na? This is sodium bicarbonate we will say. So this is a weak base. What is this? Weak base. See, even a strong base NaOH only not reacting. How this weak base will react? They won't react, na? So you can simply say no reaction. Is this clear everyone? These are some chemical properties of alcohol. Now I am saying this is alcohol. What about this? Same ring phenol. So now we need to know the chemical properties of phenol also, so that we can able to distinguish in a given sample. They are saying identify whether this is phenol or alcohol. So we can do this test by knowing which what are the chemical reactions shown by phenol and what are the chemical reaction shown by alcohol. We can able to identify or not? Yeah. So first these are the chemical properties of what? Alcohol. For what? Alcohol. So now let us discuss about the chemical properties of phenol. Okay, here itself I will discuss otherwise. Okay, so same thing that reaction that you have seen there. You tell me here first one is what? Sodium metal. Yeah, so sodium metal definitely react here, so that we will get phenoxide ion. What is it? Sodium phenoxide ion. So H place and electron becomes H2, half H2 I am writing. Next one is what? Sodium hydride. So here also it will forms Na plus. Try to write these H2. Next one what we have? NaOH. So sodium hydroxide is a base, stronger base that can abstract this proton. It means it becoming sodium phenoxide plus H2. So from this reaction, from this third reaction, that you can say phenols are more acidic than alcohol. Who is more acidic? Phenols. Because this proton is not removed by NaOH, but here this phenol proton is removed by NaOH. It means which is more basic? Phenol is more basic than NaOH. Alcohol. Everyone clear with this? Yeah. Next. CH2N2. So here I am using Lewis acid, then only reaction is taking place. If I am not using, no reaction. Here without using that Lewis acid also the reaction takes place, so that you will get something like this, OCH3. What is the name of this product? It is called as anisole. What is that? Anisole. anisole. Okay, next one. NaHCO3. See what I told you, NaHCO3 is a weak base now. So this weak base not even able to abstract this proton. So it means here no reaction. So you can remember alcohols also not reacting, phenol also not reacting. Okay. Next one, if I react this compound with FeCl3, with what I am treating? FeCl3. No reaction. What is here? No reaction we have observed. But here it is very important, ma. See here. I am doing FeCl3. What is the oxidation state of iron here you are seeing? +3. So remove this 3 chloride ions, each chlorine with -1 charge now. Remove 3 chloride ions, replace with phenoxide ions. It means FeO minus, like this now. How many we require now? Each one with 1 minus charge means 3. So this kind of complex is formed. So by this complex, this is a reddish like violet color complex. By looking at this iron complex, we can able to say, yeah, the given compound is phenol, not an alcohol, because alcohol, will it showing any reaction? No, but phenol is showing a reaction. So with this reaction also we can able to identify. Is this clear? Okay, this difference table you need to make. Yes. What is coming out ma here? Only H plus ion is removed. If you remove H plus ion, it is forming phenoxide ion. See, this is phenol now. Phenol, after removing proton, the remaining fragment is called as a phenoxide ion. Okay, see the phenoxide ion, negative charge, see, conjugation perfect, that's it, that is the application you need to know. O minus is there, minus, sigma bond, pi bond, they are in conjugation now. So like this, the base is becoming stabilized, this conjugate base is becoming stabilized. This scenario is not observed here. See, for example, you are taking ethyl alcohol, CH3, CH2OH. You remove that H, O minus. Will it be participating in any conjugation? No. Will it be stable now? No. But relatively, which is stable? That's why that proton is easily removed and forming a complexes and showing reactions with NaOH and all. But the story is not applicable here because it is not stable. Is this clear, everyone? Yeah, that's it. Okay. Done, everyone? Done with this? Please, you do it fast. Done? Done with this? Let us summarize what are the points we have discussed. Consider phenol and alcohol. Reaction with sodium, both. Reaction with sodium hydride, both. Reaction with NaOH, no reaction with alcohol but reaction with phenol. Next, reaction with diazonium reaction with diazomethane. What is that? Reaction with diazomethane. No reaction with alcohol but reaction with phenol. Next, reaction with sodium bicarbonate. Both will show? None of them will show reaction with what? Sodium bicarbonate. See, this is one of the very important point. Reaction with sodium bicarbonate. Both phenol and alcohol. None of them show reaction with what? Sodium bicarbonate. Next, reaction with FeCl3. No reaction in alcohol. Okay. Now here one thing you need to remember is phenols are more acidic than alcohols. Which is more acidic? Phenols are more acidic than alcohol. Okay. Now carboxylic acids are more acidic than phenols. Which are more acidic? Carboxylic acids are more acidic than phenols. Now here bicarbonate is there, sodium bicarbonate. That is the reagent we can use to distinguish carboxylic acid, phenols. Because phenols, will they react with bicarbonate, sodium bicarbonate? No. Here this carboxylic acid can react with NaHCO3. Sodium bicarbonate gives test with what? This is a base, this is an acid, so acid base reaction takes place here, but it is not reacting with phenol. So from this we can identify now whether the given compound is phenol or carboxylic acid. Do you got the concept? Yeah, that's it. Okay, next. Done. Okay. Next commonly asked question is phenol's acidic nature. Acidic nature of organic compounds depends on what? Electron withdrawing group more acidic, releasing group less acidic. That's it. Okay. Next. All these things are done. Okay. So now chemical properties. Now this is a very important table. Most of your alcohol chapter, aldehyde chapter completely done here itself. Just listen here. These are the chemical properties important. See, all these reagents that you are seeing here are called oxidizing agents. What they are? Oxidizing agents. So KMnO4 and K2Cr2O7 are strong oxidizing agents. What they are? Strong oxidizing agents. So when I have primary alcohol means how it looks? CH2OH. That's it, no? This is primary. Next secondary means RCHROH. Tertiary means RCRROH. Primary, secondary, tertiary. So now when I am saying primary alcohols upon treating with KMnO4, K2Cr2O7 converts into respect to carboxylic acids. What is the product form? It means RCOOH. Here also RCOOH. Okay. Next, when I treat these primary alcohols with Collins reagent, what is that? Collins reagent. Here you are going to get aldehyde. What you are going to get? Aldehyde. With pyridinium chlorochromate also you are going to get aldehyde. What you are going to get? Aldehyde. With Jones reagent we have now. Here Jones reagent means H2CrO4 and acetone. So here you are going to get carboxylic acid. What is the product formed? Carboxylic acid. Here chlorine, like any halogen, not only chlorine, X2, like it can be Cl2, Br2, I2. Okay. Oxidation gives you aldehyde. What it will gives you? Aldehyde. Next one, Cu. Okay, particularly they will mention like this. Anyways, with the copper metal here they are saying now, so you just mention this as aldehyde. What is that product formed? Aldehyde. That's it. So for secondary alcohols it is very simple. See, for primary alcohols, yesterday I told you how many hydrogens are there? 2. So what I told you? Remove that hydrogens, put O, and if one hydrogen only there means just remove this, satisfy the valency of that carbon with what? Satisfy the valency of that carbon with what? Oxygen, I told you, like this. So therefore all secondary alcohols gives you same product. What is it? Ketone. Whatever may be the reacting oxidizing reagent, all of them gives what? Ketones. Clear? Oh, okay. When it comes to primary alcohol, there are two chances. It can be carboxylic acid or it can be aldehyde, because here 2 hydrogens are there now. So from that, if I remove one hydrogen, you are going to get an oxidized product of aldehyde. If I remove one more hydrogen also and converting them into OH form, what happens? You will get carboxylic acid. So that's why sometimes carboxylic acid, sometimes you are seeing aldehyde in case of primary alcohols. Next, tertiary alcohol is there now. With KMnO4 no reaction. See, what we required, that alpha hydrogen should be there. Secondary, like this you are seeing now. This hydrogen should be there so that I can remove them and I can oxidize it to either ketones or aldehydes. But do we have in the tertiary alcohol that kind of hydrogen? No hydrogen now. Therefore, no reaction with KMnO4, no reaction here, 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 here. With copper metal, we are heating at 300 degrees Celsius now. There you are going to get alkene. By elimination, what is the product you are getting? Alkene. See, elimination means, for example, you are taking this kind of alcohol. Just check here what I am writing. CH3, CH3, CH3OH. Let us write like this. See, this OH, like alpha carbon, beta protons are there, this side, this side, this side. So, one beta proton and this OH group is removed as water. So, what happens? Elimination reaction, what is the product form? Let us say from here you are removing one hydrogen. Tell me now, CH3 this side as it is, CH3 this as it is, this one C double bond CH2. So what we got? Alkene as a product. In which case? Like metal under heating condition gives you what? Alkene. In all other cases, no reaction for tertiary alcohol. Is this clear, everyone? So make a note of this table. Yes, sir. Done? Okay, you can write later. Okay, one more reagent you can write. See, can I say this alcohol as allylic alcohol? What about these two difference? Like what makes the difference between these two? So this is called vinylic alcohol. This is allylic. What is this? Allylic. So for oxidation of allylic alcohols, what I am saying? Allylic alcohol. See, simple ma. If OH group is an sp3 carbon, which carbon? sp3 carbon, which is attached with the sp2 carbon, that you should say it as allylic alcohol or allylic carbon. Here OH group is directly on which carbon? sp2 now. So this is called as vinylic. That's it. Very simple. If that instead of OH, if we have X, you should say allylic halides, vinylic halides. Okay. So now if you treat this compound with MnO2, with what? MnO2. So the allylic alcohol converts to respect to oxidized product. Like here it is primary alcohol now, you get aldehyde. So what is the product formed here? Aldehyde. Like this. Okay. If it is a secondary alcohol, what is the product? Ketone. Perfect. Okay. Next one. Not only allylic, you can also have benzylic positions. CH2OH. So what will be the product formed? So just this will get converts into aldehyde. That's it. Clear? What is happening here? MnO2 is used as specifically for oxidation of what? MnO2 is used as a oxidation of allylic alcohols to respect to carbonyl compounds. Okay, next. Okay, next one. This is very simple. Reaction of diols with HiO4. So you can call this as periodic acid. What is that? Periodic acid. What is the oxidation state of iodine here? +7. So now what it will do is CH2OH, CH2OH. Like this, diols I am saying now. So whenever we have diols or triols or polyhydroxy groups containing compounds, upon treating with HiO4, with what you are treating? HiO4. You just need to break this bond like this. You are breaking CC bond now. Insert one OH above side, below side. That's it. What will be the product now? Tell me. CH, H as it is, OH, OH. Same, down also same product na. Okay. So how many moles you are getting? 2 moles. That is perfect. Next what to do is, on one carbon, on the same carbon, if multiple OH groups are there, the lone pairs on that oxygen will get repelled. So due to this reason, you need to remove water molecules from it. Like this OH and H. After removing, what happens? See, one H, another H as it is, this oxygen get double bond like this. So what is the final product you got? Aldehydes or ketones depending upon the compound to compound. So here we got a formaldehyde as a product. Okay. So now I will write one random compound. You tell me what is your answer. Okay, I don't want this much big. Yes, tell me. Let's make it CH3. Yeah, tell me. This is CH3, simple. What to do? I should break a double, like this CC sigma bond between carbons with OH groups only. So I should break here. That's it now. So breaking, put OH like this. I should break here, insert OH, OH. Don't break this bond. Why? Because there is no OH group here, right? Keep it as it is, like whatever it is. So now tell me what happens here. CH2, one OH already present and now newly added OH. So if 2 OH groups are present, what to do? Remove water. So if we remove water, what is the product formed? CH2 double bond O. Formaldehyde. Next do for this. See on this carbon, what I have? One hydrogen and one OH. Now how many OH you are inserting? Above one, below one. OH, OH. See now 3 OH groups are there. So what to do? Remove possible number of water molecules. How many water molecules are possible to remove? 2. OH, This one is done. Next, this side if I remove, what is remaining on that? So you should not remove this hydrogen, acidic hydrogen only you remove, like OH group hydrogen only you remove. So now what is the remaining part? H, C, OH this side, and this is oxygen. So formic acid is a product. Clear? Next, for this one you tell me fast. This carbon, one side H, another side CH3, OH, OH. Now remove water like this. So what is remaining? H, C, CH3. So what is this? Acetaldehyde as a product. Aldehyde is a product. So you got how we are identifying the products? Okay, is this clear or not? There is no OH group now, so don't break it. Do we have OH here? No. Yeah. So this will be useful when we are doing biomolecules. Like in higher studies, it will be really helpful if you are going for biochemistry part or anything like that. Okay. Next. So what to do? Periodic acid treatment means, like diols if present, break that into 2 equal halves, insert OH above and below. That's it. Okay, next. Yes. So what is the product format? Tell me. Fast. Ketone, that's it. Just identifying alcohol type, answering the product, that's it. That's it. Huh? Okay. Okay, let me change this. Tell me what is your products fast? Fast. What type of alcohol it is first of all? Done. Most of your answer is done. PCC. What it will do? PCC, pyridinium chlorochromate. It oxidizes primary alcohols to aldehydes. Okay, so remember, it's very important for you to remember that PCC always converts primary alcohols to what? Aldehydes. Whereas K2Cr2O7, KMNO4 converts into what? Carboxylic acid. So 1, 2, 3, 4. So it means butanol we got. So what about this product? So butanoic acid is a product here. Carboxylic acid. What about this Jones reagent? This is also carboxylic acid. Yeah. Now what about this copper metal under heating condition? Aldehyde. Primary alcohol now, so aldehyde. So it will be butanol again. That's it. So how simple it is? Clear or not? Next. Reaction with phenols. Reactions of phenols. See. Okay. Listen here. Phenol, upon treating with HNO3, specifically what it is mentioned? Dilute. If you do dilute nitration, like we are treating with dilute nitric acid now, so this is called nitration. Nitration of phenol. So this is dilute now. So the product will be orthonitrophenol. See, from nitric acid you are going to get NO2 plus as our electrophile. What is our electrophile here? NO2. So just tell me phenol like OH group on benzene ring activating the ring or deactivating the ring? Activating the ring. At which positions it is activating? Ortho and para position. So this electrophile goes to which positions now? Ortho and para, because it is increasing electron density, negative charges is ortho and para. So therefore electrophile will enters into ortho and para position. So what is your answer? Orthonitrophenol and paranitrophenol. Okay, now they will ask you which is major product here. Ortho product will be major. Why ortho product will be major? Because here OH group and this NO2 group have intramolecular hydrogen bonding. So due to this stabilizing factor, which is major? Ortho product. Okay. So now instead of using dilute HNO3, if I use concentrated, what is that? Concentrated nitric acid I am using. So here you are going to get a product like this. See, concentrated now, so more number of electrophiles will be generated. If more generated, that will strongly attacks on the ring. So all electrophiles goes to which positions? Either ortho or para. So how many ortho positions are there? 2. How many paras are there? 1. 1 para. So all that positions are occupied by nitro groups now. NO2, NO2, NO2. So this is your answer. In which case it will be? Concentrated. So now this is called picric acid. What is this? Picric acid. So what is picric acid means? 2 comma, see 1, 2, 3, 4, 5, 6. 2 comma 4 comma 6 trinitrophenol is called picric acid. See, previously what I told you, that phenol, will it react with bicarbonate or not? Sodium bicarbonate, phenol, no reaction, na? But picric acid with bicarbonate reacts. Why reacts? Because more electron withdrawing group, what happens to acidic nature of organic acids? Because electron withdrawing groups increases the acidic nature, na? So more withdrawing groups, more acidic nature. Therefore this phenol acidic nature increased by this 3 nitro group and now reacting with what? Sodium bicarbonate. Okay, so remember that. Done with this? Okay. Okay, now Kolb's reaction. What is this Kolb's reaction means? Phenol react with carbon dioxide in so now what happens? Ortho product and para product will be formed. Again, which product is major in this? Ortho. Why ortho product is major? See, this hydrogen bonding. So this is major. Ortho product is major. Okay. So now, what is the name of this product? Salicylic acid. What is that? Salicylic acid. What is the IUPAC name? Out of these two, which is more priority functional group? So you should say benzoic acid. If only present means benzoic acid. So now OH group is there now. So 2-hydroxy benzoic acid. What is the IUPAC name of salicylic acid?
2-hydroxy benzoic acid.
Done everyone? Yeah. So now see, CO2 we have written. How it will be now? C double bond O like this. So tell me whether it is electrophilic or nucleophilic. How to identify that? See, this central carbon is there now, attached with oxygens. Do we have any lone pair electrons on carbon? No. But pi bond is there now. Which side it will be moving?
Oxygen.
So now what is the charge you are creating? So now tell me, this is deficient or rich?
Deficient.
So carbon dioxide is best example of what? Neutral electrophile. Now see, this phenol is given. See, phenol is treated with which medium here? NaOH, basic medium. What it will do first? It's an acid, it's a base, abstract a proton from here. So forms sodium phenoxide ion. What is that? O minus Na plus. Right now? See, now negative charge is there. What it will do? Now it will activate the ring by releasing electrons. Right now? So where you will see the negative charges? See, at ortho. Like if this is coming here, this bond shift here. So Like this you are seeing now. See, previously it is aromatic, now it is becoming a non-aromatic. See, tell me, this is aromatic or non-aromatic? Non-aromatic. Now to this, what you are adding? CO2. See, where this negative charge will attack now? On the carbon. Why? Because it is positive charge. So electrophile, yeah. So now, see, I am writing this as it is. C double bond O as it is. This single bond, it is becoming single bond. See, next, like this we got. Okay, after this, see, tell me whether it is aromatic or non-aromatic. See here, what is the hybridization of this carbon? 1, 2, 3, one more is hydrogen. So sp3, what is that? sp3. So it is becoming non-aromatic compound. Now what you need to do is, you need to remove this proton. See, wherever the carbon you are adding, from there you remove proton. So remove like this. What happens finally? Like this we can write. It becomes O minus, and this one O minus. What you are removing here? H plus now. Like H plus O minus becomes OH. Okay, or you can write here that OH here. Like this. This is your final product. Okay, sodium ion is it. So now all these steps are not required. Like in your exam point of view, you just need to remember, like EAPCET and NEET, you just tell me what is the product formed in coal-based reaction? Salicylic acid. What is the reactant? Reagents and substrate? Phenols with carbon dioxide in alkali medium gives you salicylic acid. Okay, and what is the electrophile involved? CO2. See, one electrophile is entering into the substrate and another electrophile, like I am removing H place now. So what is this H place? H place also considered as electrophile only. So one electrophile is replaced by another electrophile. So we can simply say it as electrophilic substitution reaction. What is this? Electrophilic substitution reaction. So on which ring it is happening? Aromatic ring now. So aromatic electrophilic substitution reaction. Okay, is this clear everyone? Even before that nitration we studied now, that is also what? Aromatic electrophilic substitution reaction. Clear? Okay, if you are really struggling to write these mechanism steps, just remember, oh, this is releasing group, activate the ring at ortho and para position. Now the electrophile enter either ortho or para position. That's it. That is enough. Okay, that's it. Next one, Riemann-Tiemann reaction. What happens here in Riemann-Tiemann reaction? Same, phenol reacting with what? CHCl, the chloroform in basic medium like NaOH. What happens? Forms salicylaldehyde. Like in previously you seen carboxylic acid. Here it is aldehyde. Again here also which is major? Ortho product or para product? So this is major. Again what is the factor? Hydrogen bond. Done? Okay. Now what actually happening here? This chloroform is there now. This chloroform, this NaOH, they will generate an electrophile first. Like previously CO2 is directly electrophile we have, that is directly reacting, but here chloroform first react with NaOH, undergoes alpha-alpha elimination. It means this base is there now, take this proton and forms a CCl3 minus. Okay, again this will be chloride is removed from here, forms CCl2. So this CCl2 is called as electrophile. What is this? So see two chlorines are there, so you should say this as dichlorocarbene. What is that? Dichlorocarbene. So what is our electrophile in Riemann-Tiemann reaction? What is electrophile in Riemann-Tiemann reaction? CCl2. That is called as dichlorocarbene. The short form you can remember DCC. Dichlorocarbene is the electrophile in Riemann-Tiemann reaction. See. dichlorocarbon. Okay. See, just imagine from last 2 years, most of you are hostlers, like came for short term, no? So, if we have parallelly went through your IP, NEET or JE or EAPCET preparation, how it is for imagination? Now you feel like you with very confident you are going to write the exam, right? So what you need to do is, you please first you suggest to your juniors or your sisters, whoever younger than you, at your home, whenever like you will go for your certificates, you just tell them, just spend some 5-10 minutes and speak to them, just share your feedback, like, see, don't waste your time, just bring some books, if mobile is not allowed, bring some material somewhere from somewhere and go through the notes. If you are unable to understand, go to your faculties, if there are anywhere, okay, tell them like that. Or whenever they go for homes for sick leaves and all, they can prepare at home, they can do something. Okay, yeah. So now what is our electrophile? See, CCl2 has one vacant orbital and one lone pair electrons. See, to this vacant orbital, see, phenol again, in which medium reaction is taking place? Basic medium, no? So this will enter at this ortho position. I am not saying mechanism, again you feel stressed. So here finally you will get Cl, Cl, negative charge. Okay, and this will be having now a proton. See? See, 2 chlorines are there now. Remove that and insert this OH groups. So finally what it will be? On same carbon, if multiple OH groups are there, what to remove? So remove water. What is your final answer? CH. So what is this? Salicylaldehyde. Okay, same story at para position also. That will be minor. Okay. So now tell me once again. Riemann-Tiemann reaction. Phenol. Phenol react with. Phenol react with chloroform in alkali medium. Okay. So now same phenol reacting with CCl4. What is that? CCl4. So in NaOH medium only. If it is chloroform CHCl3, what is the product formed? Aldehyde. Here 4 chlorines are there now. You will get carboxylic acid. It means like salicylic acid. So what is the product formed? Major product again OH, CO, OH. When will be this product formed? It is CCl4 means. Okay. Next. Okay. Next one, reaction with zinc dust. Phenol with zinc dust. It means zinc metal, you can say. So now how this zinc converts? Zinc converts into zinc oxide. So for this what we require now? Oxygen. Take that oxygen from here. What is the remaining part? Benzene. Like this, that is nothing but simple benzene only. So phenol upon reacting with zinc dust, what will be the product? Benzene. Okay. Next one. See, we use our cloths now, like pants, shirts and all these things. Okay. So they have. So now, like zine pants will see colors now, blue color, like that. So those are nothing but dyes, like color dyes. Okay. So now we are going to prepare that compound here. See, phenol with diazonium chloride. What is that? So what is this diazonium chloride means? Like nitrogen, like this. N2Cl on benzene ring N2Cl. If it is present, what should we call this as? diazonium chloride. So actual structure should be like this. N triple bond N. Okay, this is positive charge and chlorine negative charge. It's a salt. What is this? It's a salt now. So now with what we are treating? We are treating with phenol. Okay, this happens in basic medium. Okay, so now what we know, phenol activate the ring at which positions? Ortho and para position. See, just activate the ring at para position. What is the charge? Negative charge, no? So that negative charge attached to this nitrogen. Why it is attached to this nitrogen? Because this nitrogen is positive charge. What it will do? It will take this pi bond. If it is taking pi bond, what is the charge you are creating here? That's why this positive, this carbon positive will be attached. Just imagine like that. So I'm again not explaining any mechanism, just giving that conceptual trick. Okay. Now what is the product form? Tell me finally. OH, N, double bond, triple bond become double bond. Now it is pushing this side, means that's it. This is your product. That is your product. So this is the dye, that colors you are seeing, orange, blue, all those things. Okay, next. Okay, see here, this is the distinguishing table for again alcohols and phenols. Okay, we'll come back to this table, wait for some time. See, now we'll study about ethers. What they are? Ethers. Ethers means what is the general formula? Oxygen. Like you know now water molecule. Water molecule, you know now. Just remove these hydrogens, replace alkyl groups. Then you can say that as what? Ether. Simple, you can remember in that way. Okay. Now how can we prepare? For this, the best method is what? Williamson ether synthesis. So what you will do in Williamson ether synthesis is, you will take alkyl halides. What you will take? Alkyl halides. Treating this with sodium alkoxide. Like alkoxides means what? Alcohol if be there, you are treating this with some base. What happens? That base will take this proton and forms RO minus. Alcohol, this anion part is called alkoxide. What is it? Alkoxide. So you are taking alkyl halides with alkoxide ions. So now what happens, tell me? See, X group comes out, this will goes, okay, forms what? R, O, R. Finally you got your product. Okay, now tell me, see, favorite reaction for NEET exam. Listen. What will be the product format, tell me? CH3, CH2, O, CH3. Simple now, this will be attacking here, it will going out. See, one nucleophile is substituted by another means, what is this? Nucleophilic substitution. Okay, again, this is an example of SN2 reaction. Which reaction?
SN2 reaction.
The mechanism followed in Williamson ether synthesis is SN2. Now what is the suitable solvent for this Williamson ether synthesis then? Polar aprotic, that's it. Okay, I am writing DMSO. Polar aprotic best example, or DMF. Okay, done with this. Okay, now what is the reactivity order? Tell me again. Primary, secondary, tertiary. It means this alkyl halide must be either primary, secondary or tertiary. But which is more reactive? Primary. Like that. Okay. Now tell me in SN1 and SN2 in substitution reactions I told you vinyl halides, aryl halides do not participate. Now tell me in order to prepare a compound like this OCH, I want this final product. What I am saying, I want this final product. What is the suitable things that I can take here? Phenol, see I am only giving the options also. Okay, I am only giving the options also. First one, alkoxide ion in the place of alkoxide ion, I am taking phenoxide ion plus methyl halide. This is the one thing I am taking, methyl chloride otherwise, bromide. Okay, or this as bromide, this as alkoxide ion. Tell me, out of this AB, which is suitable for preparation of this compound? First one or second one? Why A, why not B? Just now I told you that aryl halides do not participate in substitution. See, if I want to make that product, I need to remove this Br from here. Will it comes out? No. Why? Because it is in conjugation. So that's why this double bond character is there now. That's why it won't comes out. So aryl halides won't involve in the substitution. So what is the best fragments I can take here? AB, like phenoxide ion and methyl halide. So that this goes out, this will enter and gives you the final product. Is this clear? Just write these two reactions. Okay, write this. What is the name of that reaction I told you? Williamson ether synthesis. Done up to here? Okay, look at this statement. What is it? Tertiary alkyl ethers are prepared by taking tertiary alkoxide ion, primary alkyl halide. It means I want to prepare this one. I want to prepare this ether. What is my starting materials? AB, which is alkoxide ion, which is alkyl halide I should consider. See, once again look back into this. How I have decided AB here? There are two possibilities to decide. One is break here and make this as methyl halide and this remaining as phenoxide ion. Like this. Or other way is breaking this side, making what? Like here it is over, then this side if I break it will be halide, remaining is this minus. Okay, which is suitable I am asking. How you decided? Yeah, sir, this will not come out because it is having lone pair which are in conjugation. So aryl halides not involved, like this we studied. Okay, the next concept here in this, I am asking you to which is alkyl halide, which is alkoxide ion I am asking. So now tell me what is the mechanism followed in Williamson ether synthesis? SN2. What is the reactivity order of SN2? Primary. It means our alkyl halide should be primary. So which side I should break now? Which I should consider it as alkyl halide? Yeah, This should be alkyl halide, this should be alkoxide. Now read the statements once again. Tertiary alkyl ether, this is tertiary alkyl ether, are prepared by taking tertiary alkoxide, this is tertiary alkoxide ion, and primary alkyl halide. So what is my alkyl halide here? CH3, like a halide ion, like bromide or anything you take. This side what is should take the alkoxide ion? O minus. That's it. Is this clear how I am deciding this? Yeah. Next. Yeah. So now read this question once fast. Ethers are not formed in this reaction. In which reaction ethers are not formed? Tell me. First reaction you just leave. Between these two you tell me. This is tertiary alkyl halide now. What happens in tertiary alkyl halide? Will that reaction takes place in SN2? Because primary react secondary next least is primary, secondary, least is tertiary. So tertiary won't show substitution reaction generally. Okay. Now if I take tertiary alkyl halide, there is no formation of ether because this won't substitute here. But if I take in reverse tertiary alkoxide ion, this is primary halide. So now substitution takes place. This is what the previous statement in the slide. So now what is the product formed here? CH3 tries CO ethyl group. So this is ether. Ether is not formed here. Again remember, ethyl alcohols upon heating with sulfuric acid at what temperature? 140 degrees gives you ether. At what degrees? 140 degrees. Temperature also important. Like how many ethyl alcohols we are taking? 2. So C2H5OH plus C2H5OH. Remove water from here. What is the remaining thing? C2H5O, C2H5. So ether only now. At what degrees it will be? 140. Okay. If they given 170, 180, elimination takes place. There you will get ethene. At 140 only you will get ethers. Next. Done. Okay. See. This is a neat previous year question. Anisole means what is the formula? CH3. That is toluene. OCH3. Methoxybenzene is anisole. This is anisole, right? Tell me which method is proper for this preparation. Which option? Fourth option perfect now. Just now we discussed this one. Okay, what I told you here, alkyl halide phenoxide ion gives you the anisole product, because aryl halides won't participate in the substitution reaction because this won't comes out. Okay. Read this once. This is the reverse to the previous discussion. Means read it once. What is the statement they mentioned? Phenyl, methyl, ether. It means between phenyl and methyl we have oxygen. Like this now. This is nothing but what? Anisole only. You are treating with what? HI. HI is what? Strong acid. So strong acid means it will releases H plus first. That H plus ion where it will goes, tell me? This O will take that H plus. If it is taking, what happens next? Yes, you tell me. Like this it will be. Now which side I should break the bond? This side or that side? Methyl side or phenyl group side? CH3 side I should break the bond like this, so that I will get phenol plus methyl halide. See, another possible way is what? breaking this side. If I break this side, what happens? See, if I break this side, you will get a positive charge in the benzene ring. So tell me, is this stable? It is unstable. We are studying from last 3-4 days. Okay, so that's why you should not break it like this. So break in this way, you will get methyl positive charge. Then next, if you add any iodine to this or any halogen, it will become methyl halide. Like iodine is given now, I minus. I minus will be added here, you get methyl iodide. Okay, so what is your answer? Phenol plus methyl iodide. Next. Okay, we'll start aldehydes. Tell me, what are the methods we can prepare aldehydes and ketones we have? First one is from alcohols. Tell me, from alcohols, how can we do? The table you have studied just now. If I have primary alcohol, what will be the product? We can get two things, either aldehyde or carboxylic acid. So with KMnO4, with K2Cr2O7, with PCC, aldehyde, with PDC, Collins reagent, aldehydes. Next one is what? Jones reagent, carboxylic. Okay. So now primary alcohols on oxidation. See, I am just representing like this. On like it means oxidation I am doing. So what will be the product formed? Aldehydes. If it is secondary, ketones. That's it. So suitable oxidizing agent, you can use it from this table. The table we have written already. Yeah, that's it. Okay. So the next preparation, second preparation method is what? Hydrolysis of gem dihalides. Gem means what? On same carbon, two halogens. For example, CH3, CH, Cl, Cl. So on same carbon, if two halogen atoms are there, what you should call? Geminal. If an adjacent carbon we have, means like CH2, one chlorine here, other one here, you should call it as vicinal. What is that? Vicinal. Here it is geminal or gem. Okay, 1, 2 means what? 1, 2 positions, 2 halides are there, means vicinal dihalides. On same carbon, like 1, 1 position, both are them there, means geminal. So geminal dihalides upon hydrolysis. What we are doing? Hydrolysis. So hydrolysis provides OH minus and H plus now. Okay. So you just take this OH minus and add here. So which groups comes out? Chlorines. How many chlorines are there? 2. So 2 chlorines means 2 OH comes in. So that CH3, CH, OH, OH. On same carbon, if 2 OH groups are present, remove water. Possible number of water. So what is the final product? CH3, COH. Aldehyde we got. Clear? Okay. Next one. You tell me for this. What is the final product on hydrolysis? What to do? Just remove these 2 chlorines, replace OH, remove water. So finally, that's it. Ketone is a product. Okay. So what is that method called? Hydrolysis of geminal dihalides. Only geminal. I am not saying about vicinal. Geminal dihalides upon hydrolysis gives you ketones or aldehydes. Okay. Ozonolysis of alkenes. What they provide? Ozonolysis of alkenes. What we did? Alkenes we taken like these. Let us say hydrogen CH3 and some PH Me. What happens? What is the product? O3 Zn H2. Yeah. Tell me what is the final product? Break like this. Insert oxygen both sides. So now what is the product formed this side? PH, phenyl, methyl. Me means methyl, like CH3. This side double bond O, CH3 H. So ozonolysis of alkenes also provides you what? aldehydes and ketones depending upon type of alkene you are taking. Next process is what? Hydration of alkynes. Very simple, you have did this already. See, H2O, HgSO4. Tell me what happens. Yesterday also we discussed. Bond break. HOH. Where I should add HOH? Check for the stability of carbocation. Yeah. R side OH, CH side H. That's it, no? So finally you will get the aldehyde or ketone like this. CH. That's it. Okay. How we did this? Just breaking. Remove this. Remove this. If I add H plus on these, we'll get a carbocation stable one here. Add OH, do tautomerization, gives that product. Okay. Now decide here. What is the product? Benzene side, phenyl side? OH. That side? So it means wherever you are adding OH side, that you make double bond O. Other side becomes CH2, CH. That's it. Got this thing? Next. From where? From acid chlorides or acyl chlorides. So this process is called Rosenman reduction. What is that? Rosenman reduction. See, do you remember Lindlar's catalyst? What is the formula of that Lindlar's catalyst? H2 PD BaSO4. Like this we have written. Where we have used this Lindlar's catalyst? Alkynes with Lindlar's catalyst gives you cis alkenes, I told you. For getting trans alkenes, we used a bridge reduction, like sodium metal in liquid, ammonia, like that. Okay. Anyways, this is what? Lindlar's catalyst. So Lindlar's catalyst with acyl chlorides, it means what? Like this, acid chlorides, acid halides will be there. So acid halides or acid chlorides treating with Lindlar's catalyst, what will be the product formed? Just remove this halogen, give this hydrogen, get aldehydes. So what is Rosenman reduction? Tell me once. Acyl chlorides converts into aldehydes using Lindlar's catalyst. Once again, simple statement. Acyl chlorides converts into aldehydes upon treating with Lindlar's catalyst. Okay, important this one. Okay. So what is the product formed? Tell me in Rosenman reduction. What happens? What? So benzaldehyde. What is the name of this? Benzaldehyde. Okay. Next one is Stephens reduction. What is that? Stephens reduction. Okay. Reaction or reduction also here. See. R C triple bond N. Okay. You are adding this with SN like HCl in presence of SnCl2. Okay. First, who is electronegative atom here? So to that you shift this bond. Okay, you will get R C double bond NH, because this H is taken. Okay, here positive charge na, here it will getting hydrogen. See, for this what you are adding? Hydrogen, addition of hydrogen to the carbon you are doing now. So addition of hydrogen means what? Oxidation or reduction? Reduction. So can I say Stephen's reduction? Do you have any problem? No. No. Hydrolyze this. Hydrolyze this means remove this double bond like this, R, C, H, give this oxygen to that. So what is this? Finally, what is the product formed? Aldehydes. So Stephen's reduction provides what? Converts cyanides, alkyl cyanides to aldehydes. From where to where? Cyanides to aldehydes. Once again, Stephen's reduction, what is the product formed? Aldehydes. From where? Cyanides. Okay. Next. See, same, cyanides or nitriles are same, like R, C, triple bond, N. So we can call them as alkyl nitriles or cyanides. Okay, these upon treating with dibol H. So this is called, this is a reducing agent. What is this?
Reducing agent.
So this reducing agent selectively converts cyanides and esters to aldehydes. From where to where it will convert? Cyanides and esters to aldehydes. What is that reagent called? Dibol H. Okay. So what is this dibol H means? Di-isobutyl lithium. What is that? Isobutyl lithium. So it will give you what? An aldehydic product. So it is a cyanide, and ester means what is the general formula? R, C double bond O, OR. So this is also with the dibol H. What is the product formed? Aldehydes. Okay, that's it. Okay, next one is chromyl chloride test. What is that? See, you know toluene? Toluene, you treat this with CrO2, Cl2. So Cr means chromium, oxygen, chlorine here. This is what? Chromyl chloride. What is the oxidation state of chromium here? Check once. +6. Okay. So this chromyl chloride converts the alkyl group to oxidizer product. Oxidizer product means you just add one oxygen on that, like this. So what it is doing? Chromyl chloride converts alkyl benzenes to aldehydes. Once again, chromyl chloride converts alkyl benzenes to aldehydes. Okay, previously what is it? Cyanides and esters to aldehydes. What is the reagent used? Dibol H. Okay, next one. Gutterman-Koch reaction. What is the reaction?
Gutterman-Koch reaction.
Koch carbonyl. Okay, so benzene with this carbonyl group and HCl, okay, in presence of AlCl3 gives you benzaldehyde. Do you have this reaction? What is that? Benzene with carbonyl group, acid in presence of AlCl3 gives you benzaldehyde. Okay, fine. Now these are some methods of preparation of what? Aldehydes and ketones. Now chemical properties we need to know. Like you have aldehyde means like this, ketones means like this. What is the hybridization of carbon in each case? What is the hybridization of this carbon in each case? sp2. So sp2 means what is the geometry we will get? trigonal planar. So you write carbon R H double bond O. Trigonal planar means like this only, no? So molecule is a planar molecule. Aldehydes and ketones are planar molecules. Okay. Now each carbon here, aldehyde carbon and ketone carbon is what hybridization? sp2. So now tell me whether it is electrophilic or nucleophilic again. Do we have any lone pair electrons on the carbon? No. What type of atoms attached to it? Oxygen means definitely electronegative. The pi bond shifts towards? So now what is the charge you are creating? So this carbon is electrophilic carbon. Which carbon? Electrophilic carbon. In both aldehyde and ketone, the carbonyl group carbon is what? Electrophilic. Is this clear? Okay. Once after knowing this, now what type of groups attached to it? One is alkyl group, hydrogen. So we know alkyl group means releasing group. So now what that group will do, electron releasing group means releases electrons into this side, carbon side. It is electrophilic. Electrophilic means what it requires? Electrons. If we attach alkyl groups, that releases electrons and stabilizes this carbon, right? Now tell me, which is more electron deficient, first one or second one? Aldehyde or ketone? Aldehyde or ketone, once again. Aldehyde. Why aldehyde? Only one alkyl group is there, but here two alkyl groups are there, so two will releases and that will give some electrons, less, makes it less electrophilic. So which is more electrophilic out of these two? So I am making a statement, aldehydes are more electrophilic than ketones generally. So what is that statement? Aldehydes are okay. See, if there is more electrophilic, I have two centers, A center, B center. Both of them are electrophilic centers. Both of them are what? Electrophilic center. Now I have one nucleophile only, where this nucleophile will attack on A or on B. The one which is more electrophilic, on that center this nucleophile will attack. Yes or no? So I am saying A is more electrophilic center. Then it attacks on what? A. Right. So now look at this. I am writing two compounds, CH3, CO, H, CO, H. If you want C also I will insert CH3, CO, CH3. So tell me, all three are electrophilic centers or not? All three compounds are electron deficient, like electrophilic centers are there. But where the nucleophile will be added easily? B. Why? Because there is only hydrogens. So this is more electron deficient. So nucleophilic addition is easy. So what you are studying here is nucleophilic addition reactions. What is it? Nucleophilic addition reactions. Okay? And reactivity of aldehydes, ketones towards nucleophile depends on what? Their electron deficiency. So like this, reactivity directly proportional to electron deficiency of nucleophile, directly proportional to electron deficiency on carbonyl group. So which is more electron deficient? B. So that is more reactive. After that, A. After that, that's it. This is a nucleophilic addition order. See? A nucleophile is coming. So where I should add this? Here only, no? So this bond shift towards, so what happens, R O minus H, this Nu means any nucleophile you can consider. The next what happens is you need to just hydrolyze it, like water you add. That from there that H plus is taken by oxygen, converts into R, C, OH, H, Nu. This is your final product. Okay. Now let us see one question. Okay. Answer this question, what they are asking. Which one is most reactive towards nucleophilic addition? Which is? So what I told you, more electron deficiency, more reactivity towards nucleophile. So which will undergo nucleophilic addition readily? See, this is aldehyde first. Aldehyde or ketone? Aldehyde. What about this? Ketone. This one? This one? Aldehyde. So we know aldehydes are more electron deficient than ketones. So definitely aldehyde is our answer. So A or D. Here what type of group we have? Only one methyl group, smaller group, that is bigger group. Which is more electron releasing group? Ethyl group is bigger, means that is more releasing. This is less releasing. Less releasing, more electron deficiency. So this is more reactive. So A is your answer. Okay. Between A, D, it should be A. The next D you should answer like this. Next. Okay. Answer me this one. Which one is most reactive towards nucleophilic addition? C, why C or why A? Yes, electron withdrawing group is there now. All the centers are aldehydic center, that is fine. But what we require, more electron deficiency, more reactivity. If there is electron withdrawing group, withdraws electrons towards themselves, create more electron deficiency here, so nucleophile enters there easily. So therefore which is more reactive? C. Okay. After C, you tell me? A. Okay. After A, B and least is D. Why? Because here what is the group we have? Releasing group. So you can say simply two statements. Electron withdrawing groups increases rate of nucleophilic addition reactions. What they will do? Electron withdrawing groups increases rate of nucleophilic addition reactions. Whereas electron with releasing groups decreases rate of nucleophilic addition reactions. Now we will see with one more question. Yeah, tell me now, fast. What is the answer? What type of groups they have? Withdrawing groups. Remaining everything is same. So electron withdrawing groups, what they will do? Rate of reaction increases. So which is more? A. Next. Between A, B, why you are saying A? Both of them are aldehydes only. But this is at meta, this is at para. Mesomeric effect applicable only at ortho and para. No at meta. So here we have minus M effect and minus I effect. Here only minus I effect, no M effect. That's why A first, B like this. Okay, next. Okay. See, to the aldehyde or the ketone, what I am adding is, I am adding HCl. What I am adding? HCl. So this takes place in presence of basic medium like NaCN I am taking. Now what happens, tell me? Which group will attack on this? From this or from this? Cn minus. So where it will attacks? Carbon. So R, C, it goes upside, O minus, H, here what I should add? Cn, and this Na plus here, like this. Followed by hydrolysis, it means water, if we add, what happens? This becomes OH, R, C, OH, H, Cn, like this. Okay. See, they won't mention this water and all, they just mention like this. So finally what you need to make is here OH, like this. Next one, so once read the statement what they are saying. Cyanohydrines are very useful compounds for synthesizing many other organic compounds such as alpha hydroxy acids, amino acids, alpha beta unsaturated. So the product formed here is called what? Cyanohydrine. What is this? Cyanohydrine. So now it is used for what purpose? Alpha hydroxy acids. So this alpha hydroxy acids, how we will get from here? What is the name of this compound? Cyanohydrine. You just add water now. If you add water, this cyanide means how many bonds are there? C triple bond N. So you are hydrolyzing this group only now because everything is saturated there. So C R H OH. Cyanides upon hydrolysis gives you carboxylic acid. What they will give? So cyanides C triple bond N upon hydrolysis gives you COOH, carboxylic acids. Okay. So cyanide is converted into what form now? Carboxylic. So now tell me what is the name of this compound? Carboxylic acid is priority na 1, 2 or to this is alpha. So I can say alpha hydroxy carboxylic acids, can we say? Yeah. Next one. From these we can also prepare amino acids also. What we can prepare? See, if I replace OH with NH2, what happens? Alpha amino acids will get. If I replace OH with NH2, so it means we can also prepare amino acids and the next alpha beta unsaturated compounds. Okay, you go to break, we'll discuss in the study over time.